Good afternoon, everyone. My name is Shinya Tanigawa. I belong to Faculty of Agriculture, Kyoto University. Today, I will tell you about my study, the relationship between light reflection from cathode's pupil and serum vitamin A level. Firstly, let me talk about the background of my study. Takao-san and Han-san have already told this kind of background. So I will explain simply. Look at these two pictures. The left picture shows the normal beef and the right picture shows the high quality beef. High quality beef has high marbling score, and especially Japanese likes to eat such a high quality beef. To make better beef, reader has to control the serum vitamin A level. This graph shows the desired time series of serum vitamin A level to make better beef. In middle fatting phase, this blue area, in middle fatting phase, reader has to control serum vitamin A level lower. However, under the 30 IU, international unit per deciliter, cattle get a disease that is called vitamin A deficiency. So breeder has to control the vitamin A level about between 30 IU per deciliter and 50 IU per deciliter. So strict management of for the serum vitamin level is needed. Currently, a main way of measurement for serum vitamin level is blood assay. But blood assay has some disadvantages, such as high cost, time consuming, and stressful. So a simple and rapid method is desirable. Then our research group focus on the image processing of cathode's pupil. In my study, I measured the light reflection on the surface of pupil. Light reflection means this surface reflection of LED rings. According to previous study, surface of eyes become dry and rough by vitamin A deficiency. So I made a hypothesis that light reflection is reduced and scattered when the changes of surface, such as dryness and roughness, occur because of vitamin A deficiency. So the goal of our research group is to establish a rapid method of serum vitamin level measurement by image processing of cathode's pupil for production of high quality beef. And the objective of my study is to examine a relationship between serum vitamin level and light reflection on the surface of cathode's pupil to analyze RGB components and those variants around the halation area. Here's the material. Test cattle are 42 heads of Japanese black cattle. The period of experiment is from May to December in 2011. And the range of ages, cattle's ages is from 12 and to 23 months old, like this range. Every month, data of images and vitamin A are taken. This is a device. Imaging condition is like this. 2CCD camera can get color image and NIR image at the same time. The lighting device is white LED rings and NIR LED rings with PL film. In front of the lighting device, there is a 100 millimeter tube to prevent ambient light and keep distance from camera and eyes constantly. This is a method of experiment. Firstly, we cover the black cloth over the cattle's head to dilate pupil for 120 seconds. And next, we put NIR LEDs on and detect pupil area, pupil position and fix camera. After that, white LEDs on and we start to take images. experiment is like that. And here is an image processing. This is the original color image. Firstly, the color image are separated to grayscale of RGB components. This is a grayscale of B component. Then the grayscale of HSI are calculated. This is a grayscale of H. Then the grayscale of H is binarized and reduce the noise to detect the pupil. At that time, I decided the ROI, range of interest. Here, black ring part is halation part. I removed the halation part. Finally, I took RGB components in ROI. From now, I will explain the result. Firstly, I explain the individual result. Individual means one cattle, one cow data in one graph. This slide indicates the relationship between mean value of RGB and serum vitamin A level. Look at the left graph. This graph shows the time series data of serum vitamin A level and mean value of R. X-axis is months of experiment, and Y-axis is serum vitamin A level and mean value of R. You can see when serum vitamin level goes down, mean value of R increase. So mean value of R is negatively correlated with serum vitamin A level. Next, look at the right graph. This graph shows the linear correlation between the serum vitamin A level and mean value of R. This graph also shows negative correlation. Then look at the table 3. This table shows the number of cattle with correlation between mean value of RGB and serum vitamin A level. You can see 33 of all cattle get correlation, negative correlation with serum vitamin A level. Also, mean value of G and B get the negative correlation. Next, I analyze the variance of RGB by same way. Look at these two pictures. These two graphs shows the relationship between serum vitamin A level and variance of B. When serum vitamin A goes down, variance of B decreases. So variance of B is positively correlated with serum vitamin A level. Then look at this table. Variance of R and G have little correlation with serum vitamin A level, but variance of B 18 of all cattle get positive correlation between variance of B and serum vitamin A level. Next, I will explain the statistic result. Firstly, I separate all image data by range of serum vitamin A level, like under 20 IU per deciliter, from 20 IU per deciliter to 30 IU per deciliter, like that. And then I take average value of RGB components and serum vitamin A level in each group, like this. Then I plot the data. One plot shows the one vitamin A group with average value of serum vitamin A level and mean value of RGB. you can see mean value of RGB is negatively correlated with serum vitamin A level. And R square has high value. And next, I calculate the I intensity value. Intensity value is calculated from this formula. I is also negatively correlated with serum vitamin A level. Then I analyze the variance of RGB by same way. You can see variance of R and G has little correlation with serum vitamin A level. However, variance of B has a positive correlation with serum vitamin A level. Then let me talk about the discussion. I think I consider generally mean value of RGB become decrease and variance of RGB become increase when the surface of ice become dry and rough caused by vitamin A, less vitamin A. But results are different from this consideration. I guess light reflection is not only from the surface but also the other part. Look at the eye of diagram of eyes. Retina is this part, which is eye gland. So I guess light reflection is not only the surface, but also the retina. Then look at these two graphs. These two pictures shows the these two pictures shows the color change of retina. You can see when serum vitamin A level goes down, retina color is bleached. So I guess intensity become higher. So my result follow this color change. And I'd like to show you the result in 2010, last year's result. You can see the relationship between mean value of B and the serum vitamin level is positive correlation, and the relationship between variance of B and serum vitamin A level is negative correlation. This is opposite result from those in 2011. But in this result follows a general consideration. So I guess this is because the brightness of images because of the imaging condition in 2010 image is dark, so reflection from surface strongly affect, I guess. And in 2011 image is bright, so reflection is from retina also strongly affect, I guess. This is the final slide. I conclude that light reflection from the eyes has a potential to become one of the components to measure the serum vitamin A level. And there is a possibility that properly darker images are better to detect light reflection from the surface of eyes. In the future, this study will be used in multivariable analysis with researches about color change and shrinking speed of the pupil. At that time, a new measurement for serum vitamin A level will be established. That's all. Thank you for your attention.
One thing I found, what's the difference between your result and Takao's result? Very close. Some of them very close.
Yes, very close. However, RGB components I used this large RGB components is different from Takao-san used small RGB. Small RGB.
Red gray level, red color component, gray level.
Yes.
Oh.
Gray level.
Takao-san was the ratio.
Ratio, yes. Chromaticity value.
Then, what's your objective? Your project objective was? Light reflection. Light reflection and vitamin A.
Yes.
So, yeah, you have to explain about that. What's the light reflection? Takao-san showed the RGB component or RGB ratio, color ratio. Yours light reflection, surface reflection.
Yes.
Maybe some of us not understand it.
In the presentation, what will be the order between your presentation, Hansen presentation, and Takao presentation? Who go first?
That order. Hansen, Takao-san, this order.
If Hansen go first, I think what Hansen's slide should include one slide indicated from this laboratory, you have 3 presentations. Your presentation covered this component, Takano-san covered this component, so the audience will understand is 3 presentations from this lab. Because if not, I can see here is that a lot of duplication, a lot of slides that you use are the same. And the worst thing is the conclusions are slightly different. Your conclusion is different than Takano-san, different than yours. So you need to work out the conclusions. Because you use different techniques. Because I'm sitting here, I listen to her presentation result is inconclusive, you are much affirmative. So I'm kind of saying, okay, what is the outcome of this experiment? So what you need to do is highlight 3 presentations. Yours is focused in one area, yours is focused in one area, your focus in one area. Very quick, short, one slide. So audience, 3 presentations, 1 to 3. Okay? And then you can cut off some of the duplications.
We better discuss among us. Those 3 presenters should know how you share your part in the whole research. Maybe Hansen show us who will be in charge of something like that. Especially you and the Takao-san are very similar. So maybe you have to make clear about that. What's the difference from Takao-san?
Since I have not much information, I sit here and I listen to you. It seems like your experiments are the same, but actually it's slightly different the way you interpret the data. But it's the same animal, same data, right?
Yes.
Okay. You're using the same animal, using the same measurement, but interpret differently.
Because ROI is different.
Yeah, that's right. ROI is different. Then, he's focusing on the light reflection, surface reflection. But yours, some color of the.
All colors different.
Yes. So basically, his aim is different. Just no color necessary. Just some intensity of the reflection,
yes,
or some dispersion on the surface would be the point. Yours.
It also seems like I'm looking at his data. You have a lot of data on animal have the vitamin A concentration around 30. So your data is slightly different than Takano-san's data. Seems like your data points are different in the actual vitamin A concentration. So you can see your concentration is different. Go back to the other. Go back to, I have a question for you. Go back, maybe 11.
Okay.
Yes, go back. Go further back one more. Okay. Okay, this one is okay. example, the what I'm trying to indicate, you have a vitamin A concentration from 30 into 70. If you look at the data point from between 20 and 50, your data doesn't look so bad. Those are your concentration range that you're interested in. So you have something called your range of interest between 30 and 50, right? Between 30 and 60.
Yes. Lower value is
If you look at that, your data
important.
doesn't look so bad. Your data looks pretty good. It's just a high concentration might have problem. Keep going on the slide. Well, one slide I have a question. Slide 16. This is everything.
So
Okay, so for example, on the y-axis, you have time scale 0, 1, 2, 3, 4, 5. Those are data point. What you should do is adjust the time scale into actual day,
actual day.
because they are not linear between 1 and 2, 2 and 3, 3 and 4. Those are different days.
Yes.
This period is
So when you
Yes.
do that, the graph will look very different. Do you understand?
Yes.
And then you only concentrate in the level of concern between 20 and 50. My data point doesn't look too bad because I can exclude the 60 because I don't care about 60 because that's well safe level.
Yes.
So
Exclude.
so that's a different way to interpret data depending on the outcome. Same question I asked the congressman, what do you really want to accomplish? You want to develop a method to measure many concentration, or you want to have measurement into the alert concentrations? If it's alert concentration, you might have a method already.
Just a couple of points. You said experiments were done from May to December, but you showed May to November on the slide.
Sorry.
That over there. It says May to November, but you said May to December.
Sorry.
Slide number 10 I found a bit confusing. It wasn't clear to me. You were separating out the colors, RG and B, and then you combine them because you're interested in. You're not interested in colors, is that right?
Yes.
Interested in white light. And then you talk about the mean value of R is the most correlated with vitamin A. So now you're talking about a specific color. So I'm
Yes.
not quite sure what you're trying to say there. What is important to say? What are you trying to say there?
What do you want to
What's
say
the
about
message?
I think same tendency. RGB, all components is same tendency is important, I think.
That means
Higher reflection, all color value reflection increase, change.
Just a point of English again. You had statistics. Statistic, singular. Stop. Yeah. So that should be an adjective. Statistical results. Statistical results, not statistical. Or just statistics, plural. I think you could speak just a little bit slower as well.
So,
Yeah, just a little bit slower.
Maybe you also should put the title of this table on one line. Maybe it's better to.
Table
Caption.
5,
Yeah.
make it big.
Make it bigger, yeah.
yes.
This will be slide number 10. And just in this table, you use that some tendency, negative or positive, based on some plot which R square is larger than 0.1.
Yes.
So is it acceptable to say that with the R square is larger than 0.1 and you can say that this some tendency is positive or negative? Is it okay to use this value? R square is larger than 1, you can say, oh, this one is negative, this one is positive. Is it acceptable?
Please.
In this table, you say that this data has negative correlation or positive correlation based on some plot, and you see the R square is larger than 0.1.
Yes.
This method is acceptable to say it like this. The R square is larger than 0.1, and then I say, oh, this negative, oh, this positive. Is it acceptable?
That's not a common way. I don't know what the best way for you would be. That's not enough data to show the R square. Or another thing is that R square doesn't mean anything. Just delete it. To me, it doesn't make any sense. So if it doesn't make sense, don't include it.
Because that's the table just listing number of cattle, not result of test.
You have 42 cattle.
All 42.
Or 42. Yes.
Show negative correlation, no correlation.
Maybe, yeah, you discuss later.
Are you using the same data? Because the data very similar to this.
Same. Same data.
It's the same data.
But my data is ratio. This data is not ratio, but R to B3. I don't analyze about large RGB, just sequence.
All R square is more than 0.1. You mean all data, 42 cattle, has more than 0.1 R square.
No. This cattle get lower than 0.1 R square. So I judge no correlation.
I think it's time up. Maybe later we continue. We can improve. Okay, thank you.